Hey students, this is lesson 4.3, patterns and nonlinear functions. In this lesson, we're going to learn how to recognize and start to write equations for nonlinear patterns. All right, go ahead and do the review. I'll check back with you. All right, a linear function is a function whose graph is a non-vertical line or part of a non-vertical line. So here's three examples of linear functions. A nonlinear function is a function whose graph is not a line or part of a line. So it doesn't go straight. So here's three examples of nonlinear functions. All right, we're going to take a look at some of those and see if we can't start to recognize when a situation is nonlinear. So this first one says, we want to just classify this function as linear or nonlinear. It says the number of centimeters is a function of the number of inches as shown in the table. Is the function linear or nonlinear? So to figure out if it's linear, one way we can do it is just by graphing it. So, and then look and see if it looks like the dots line up. So at 1 inch, we're going to put a dot at 2.54, which is about there. At 2 inches, we're going to put it at 5.08, then 7.62, then 10.16, and to check and see if it's linear, we would just take a straight line and see if indeed those dots line up, and they seem to on this one. So we're going to say yes, it's linear. And let's talk about one other thing as long as we're doing that. If it's linear, we should be able to write a simple equation. And what we need to know is what these numbers are going up by. There is a straight line. And if we look closely, we can see that we keep adding 2.54 for every inch. So there's 2.54 centimeters per inch. So we could write something like this. Centimeters equals 2.54 times the number of inches for our rule. And that's a linear rule. All right, you try that. All right, problem 2, representing patterns. Table shows the number of calls made in a phone tree during each level. Identify the pattern to complete the table. How can you represent the relationship using words, an equation, and a graph? So we recognize that the number of calls seems to be doubling. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, times 2 is 32. And so our ordered pairs are 416 and 532. Okay, to make a graph of that, we just need to estimate where these ordered pairs are. 1, 2 would be about right there. 2, 4 would be about right there. 3, 8, 4, 16, and 532. And if you look closely, you'll notice that these are definitely not going to make a straight line. They make a curve. So we know this is nonlinear. And so what's happening is as the level increases by 1, the number of calls doubles. That's how we would represent this relationship using words. The equation for this relationship, notice we keep multiplying by 2. When you repeatedly multiply by 2, that indicates an exponent with a base of 2. And this power will tell you how many times to multiply by 2. Now we just want to check to make sure, is 2 to the first equal to 2, 2 to the second equal to 4, 2 to the third equal to 8, and so on. And that is true, so there's our equation. All right, you try something like that here. You can think of a function as a rule that you apply to the input in order to get the output, and describe a nonlinear function with words or with an equation just as you did with linear functions. So check out these ordered pairs. We have 1, 1, 2, 8, 3, 27, 4, 64, 5, 125. What is a rule that represents this function? This one's kind of difficult for students. They don't recognize this pattern right away. But don't, if you remember, we've looked at this pattern quite a bit so far, where we have the number multiplied by itself to get the output. So 5 times 5 is 25. So the next number would be 36 because 6 times 6 is 36. Think about that for a second. And in this one, again, we could think of some way to use 2 to get 8, some way to use 3 to get 27, some way to use 4 to get 64, some way to use 5 to get 125. And in this function here, we were multiplying the x value by itself. So one thing you might want to try is multiplying it by itself 3 times. And if you did that, 1 times 1 times 1 is 1, 2 times 2 times 2 is 8, 3 times 3 times 3 is 27. And so the rule that represents this function is the y value is equal to the x value to the third power, or x cubed. All right, you try one of those. All right, here's the lesson check. Go ahead and work that out, see if you can figure it out, and be ready to share that next time we meet in class.